Okay, so 6.1 we're going to be talking about start talking about probability, and in this case we're talking about statistical significance. Now we just looked at the normal curve. Remember I told you that we had the two standard deviations was 95% was contained within two standard deviations. That's important because that's where statistical significance lies. Remember, one of the things as in the chapter said that if something is more than two standard deviations away from the mean, it's an outlier. It doesn't happen a lot, and so therefore, if it's 95% of the data is within two standard deviations, then only 5% of the data is outside of two standard deviations. That's not a lot of stuff. That's a 1 in 20 chance of that occurring. So that's what this is going to be about, this 6.1. So statistical significance is, here they say is the definition, a set of measurements or observations in a study is statistically significant if it is unlikely to have occurred by chance. Okay, and we usually give it a value at some point, and they call that value alpha. When we start getting into the next couple of chapters, we're going to see alpha, and that stands for statistical significance. So, and here they're going to give you a couple of examples, just to break down and just to think about them. So we have a detective who finds that 25 out of the 62 guns used in crimes were sold at the same shop. Well, that's a lot of guns to be sold at a single shop. So something funny is going on there. And so that probably has statistical significance because there's lots of gun shops. So the fact that you find just a single shop that's selling almost half of the guns, that's probably unusual. The second one here, we have they're talking about global warming because everybody loves global warming, and that 5 of the highest years in the 20th century occurred in the 1990s. Well, that probably shouldn't happen, okay? Because they're saying here by chance alone, there's a 5 in 100 or 1 in 20 chance of being one of the 5 hottest years. Well, having 5 of them in the same decade, half of the decade is the hottest, 5 years, and that's probably not normal. It probably can't happen by chance. So it's statistically significant, most likely. And here's the last one: a team with the worst win-loss ratio beats the defending champions in a single game. Not in the championship, but in a single game. Well, this isn't statistically significant because while the worst team in basketball is going to win very few games, they are going to win some, and on any given night they could beat any given team. So, it is possible that they will beat the best team once out of their couple of wins that they have. So that has no statistical significance. And here now we're going to talk about populations. Well, so if we have a sample of something, and here they're saying they have a sample of 100 people who are going to get this treatment, and 100 people are going to get the control treatment. And they find that 30 people in the treatment group got colds, while 32% of the control group got colds. Is the herbal medicine formula effective? Well, and what they're saying is that because it's such a small difference between the two of them, that there's probably no statistical significance. If they had found that 30 people got colds in the treatment group while 62 people got colds in the control group, then there might be something saying that this herbal medicine was actually useful. But because the numbers were so close together, there's not that big a difference between the two, so there's no problem. If we did the test, there would be no statistical significance. And we're going to eventually show you how to do those tests. It again has to do with z-scores. So that z-score is going to come back around. Okay. So, and when they're talking about quantifying them, the probability of an observed occurrence, having a 1 in 20 or 0.05 level, happening 0.05 or less, a probability of 0.05 or less, that is the statistically significant at the 0.05 level. If something doesn't happen, it has no chance probability of happening by chance, and a 1 in 100 chance that is statistically significant at the 0.01 level. Or here you'll see alpha of 0.05 and alpha of 0.01. I know I'm pointing with the mouse and you can't see it, but I don't have any way to draw on the map here. But so that's what this is, 0.05 level, that usually you'll see is alpha equals 0.05. And the 0.01 level you'll see is alpha equals 0.01. So this group here, again, we're talking about a study that was done. This is the Salk polio vaccine done in the 30s and 50s. They took 200,000 children and they gave them a treatment. And they took 200,000 children and they gave them a placebo. And they found that 33 out of the 200 children got polio, whereas 115 out of the control group got polio. And when they did all the math, they found that the chance of this occurring was less than 0.01. So they're asking, well, what is the implication of this? And they're saying, well, the result that because this is statistically significant at the 0.01 level, meaning there's a less than 0.01 chance that it occurred, by chance, by just happenstance, we can be fairly confident that the vaccine actually worked. And so that's what we're looking for. That's what they do in these hypothesis tests, which we're going to talk about later. But we're trying to bring in probability first before we can get to that. So probability is important in the fact that we have to use the area under the curve, under that normal curve, remember that number that we get, that percent number, that's really a probability as well. And we're going to see why in a couple of seconds. So in section 6.2. So that's the end of this one, and the next section we're going to look at is 6.2, and we'll clear up a few things of why normal curves are probability.